hello viewer, and hello to this really beautiful and special member of the photosynthetic community, Asplenium rudimeraria. And the genus is one of the all-time greats, and this little guy is not to be discounted in its beautiful contribution to the life of the place and the diversity of this region of the crust, which not only is infested with a terrifying death ape, but it also includes this beautiful photosynthetic community just thriving, chilling, soaking up the rays on this basalt flow here, this basalt ridge, so-called trap rock ridge, because the basalt is so resistant to erosion, exposed here by the glacial caress, which of course came this way and rounded this pillowaceous basalt. But for our photosynthetic friends, we're just marveling. It's a specialist in this basalt cliff. It only occurs on this basalt cliff, and therefore its range in the county is very restricted, and I think it's even called endangered. But good friends with Pelea atropurpurea, this moss, whatever that is, Dryopteris marginalis, and we know that this basalt is full of nickel and iron and magnesium. I mean, maybe the iron is useful, but the nickel and the magnesium are hard to live with. And this creature, this lineage of just fearless, forward-faring life, unstoppable, adapted to here, and just it appeals to few other forms of life. I mean, definitely this beautiful lichen that has some photosynthesizers embedded in it that are allowing it to live there, but that's a fungus. And Pelea atropurpurea and a few pieces of moss, and that's it. But it's spreading, and showing, I think, what I was saying, that tenacity, that incredible tenacity, makes it. I think that the persnickety Germans are very unhappy. They spend a lot of time probably spraying it with poisons so that the precious mortar in their cracks isn't harmed by the tenacious roots of this photosynthesizer, this Asplenioid. And yeah, the Asplenium genus is characterized in the whole Asplenium family by these linear sori, these sort of zones of sporangial activity where the spores are produced, and during the wind dispersal, the air dispersal phase of this creature's beautiful life cycle, those spores are going to drift along to somewhere like there. And they're going to root along with that plant, whatever that is, something equally specialized to this very this rock rich in heavy metals, they're going to take root. And those little leaves are going to grow, divide. Well, but not before the crazy fern part of the fern life cycle, where a whole nother little plant that looks like a little liverwort has sexual reproduction and quickly grows into, once it's fertilized, into this spore-bearing phase of this beautiful life form that shall not be sneezed at, that shall not be ignored, because, you know, because praise is its portion. Praise and appreciation. I'm just marveling. I mean, and here we go, another beautiful Asplenioid nestled into this dry crevice, except somehow getting some water, adapted to the dry conditions, similar to Rudimeraria, not only found in dry conditions, but adapted to them, and often find this Asplenioid under an overhanging cliff, growing where few other plants even attempt. I mean, we have some dead moss, we have a ranunculoid. That's a familiar presence. But this is Asplenium trichomanes. And like the other aspleniaceous photosynthesizers, it has those linear sori, those dark lines are spore-producing structures, and they're laid out in a linear fashion, which is distinctive of the genus and maybe the whole family. We got the new leaves coming in there. These are last year's leaves. It's an evergreen photosynthesizer, and just an overachiever, worthy of admiration, worthy of respect for being at home in an incredibly inhospitable microhabitat. They're all along here in this, and you continue down there, and they're all along here in this this fault structure. You see this fault structure in the rock, normal faulting, extensional tectonics revealed by glaciation. And what can we say? So number 2 in our inventory of the Asplenioids, just admirable in every way. Very small. You'd think adapted to the cliff, you never see them growing in on the ground in the forest floor, I think they would just get they would get covered by leaves, and they would just never get a start. But they're at home just in the rocks, almost without any water. They're also at home among the mosses. And down here, I noticed another one just beyond this beautiful Macranthes virginiensis. That's an aspleniaceous photosynthesizer doing what it did so many millions of years ago when the earth was rock and waste, but there were aquatic zones, and there were mosses, and there were plants that needed water to reproduce, like all ferns and mosses. Their little gametes, their flagellated sperm, need to swim through the water, and this is no different, but somehow it grows in these dry conditions. I don't know how that's possible, but it does. And anyway, here you see it doing what it did so many millions of years ago, getting up above the mosses. These mosses are gametophytes, and that's the photosynthetic form of the gamete, the haploid part of the life cycle, corresponding to the sperm and the egg in animals. But it grows, and it grows as this gamete. But the fern is a sporophyte, and the gametes, I've never seen the gametophytes. I don't know where you find them. I mean, they're somewhere. But here is a sporophyte, and it's producing those spores, and it's getting up above the mosses into the air. And those spores are going to drift through the airs, and it sustains itself above the mosses, so it can hack it. It can do its thing along with all those gametophytes that you'd think might choke it out, but no. It's just here. The world is a survivor. The world, for it, as far as this little asplenioid is concerned, the world never really changed from this rocky, inhospitable place with lichens, mosses, and, Macranthes is here as well. Macranthes came later, but the asplenioids were here first, and it's just worthy of admiration and worthy of respect. Asplenium trichomanes. Turning now to Asplenium rhizophyllum, the root leaf, the leaf root, the walking fern, quite different from the other aspleniaceous plants. three other, in that the leaves are simple. The leaves do not have leaflets. They are simply leaves. And it's a far famed Asplenium. It's in the textbook. It's an exemplary member of its family. It's figured out the cliff dwelling lifestyle like few other photosynthesizers. It's here, and it's a huge patch. I've never seen a patch this big. I don't think this is the biggest patch I've ever found. And just a few feet away from Asplenium trichomanes, and there you go, there's the linear sori. Extremely distinctive. Of course, you look at the reproductive structures of plants, and those are the most widely shared, the most distinctive characteristic features of most plants, including ferns and flowers. But so you know it's a spleniaceous from that, but it's here on this cliff, and I think it prefers a little more moisture than trichomanes, but why is it so famous? Why is it so far famed? I've been looking through this stand of them, and I found an example. I didn't find this is the only one I found, but here it is. So there it is. That's called a bulbet, I believe. A little bulblet, another fern growing from the leaf, from the tip of the leaf, and you can see a little bit of root. It's not unusual for angiosperms, flowering plants, to root from branches, but to root from a leaf, that's not what they do, but that's what this photosynthesizer does. And it's walking, aptly named walking fern, because the more the leaf grows, the longer this tip shoots out, and it not only mostly downward, but not only downward. Some of them go up. Some of them are like, we want to walk up, and there's a young leaf, no tip yet, no sori, plenty of sori, plenty of tip. So it's a famous spleniaceous plant. Look at that tip. That's so long. I don't know when the bulbets grow, but maybe it's later in the year. See, this is what I'm talking about. Sometimes they walk straight up. They go up. Sometimes they go to the side. And it's an adaptation to coexisting on these cliffs with these moss and these other plants. And it's a way of spreading without doing the whole spore drifts through the air, wind dispersed, lands in a appropriate environment, and grows not into another, this is the fern life cycle, not into another plant with leaves, but into a different stage, a gametophyte, and that gametophyte is what what participates in sexual reproduction, and then the gametophyte, once it's fertilized, develops into a sporophyte, and the gametophyte part dies and the sporophyte part lives. But rhizophyllum has found a way to spread without that whole rigmarole, simply by walking, by sending out the beautiful tip of the leaf and rooting from that tip, growing another plant. And you can find places where, oh, that black and white warbler. You can find places where they've done it. See, here's a great example. So first it was growing here, I think, probably, and then it walked over to here and it regrew, and like that, and on it goes. And you see there's a little flap, and the spore producing bundles are arrayed underneath that flap. I think that's called an indusium. And last but not least, the fourth member of an impressive and beautiful family and genus in Franklin County, Asplenium plataneuron, the wide-stemmed spleenwort, the wide-stemmed Asplenium. Similar to Trichomanes, but demonstrating something here. This is I don't see any new leaves on this one, so I'm a little worried about it, but we have the old leaves from last year. We see the little linear sori. They're short, but they're linear. And we see the leaves have these little ears, these little auricles, and that's distinctive. But what's also distinctive is that the fertile fronds, the fronds with the sori, are larger and longer and more erect. The purely photosynthetic fronds, like, oh, well, I didn't mean to do that, but like this little guy, it's fragile, are short and more close to the ground. So we see it doing what ferns do, getting up above the mosses. And this is the Asplenium, unlike Rudimeraria, Trichomanes, and Rhizophyllum, which has a capability to venture out away from the cliff. We see in this case the rock face is slanted back, so it's not as overhanging, not as steep. And we have it growing towards the foot of the rock, and its long fertile fronds, I think, have the capability to hack it to some extent in the presence of leaves, and they will venture out onto the forest floor a little bit. Oh, this is good. So just around the corner from that plataneuron that was looking rather peaked, we have one showing its mettle, showing its surviving capabilities. These are the old stems, and these are brand new stems. And look, the little auricles, the little ears, the new leaves are a little triangular, unlike Trichomanes, where they're like little discs almost. And this is that, I think probably, well, I don't know. It could be a fertile frond eventually, but it's getting up there. It's going for it. Yes, it is hard to see, but you can see the beginnings of spore production. The little linear sori, the little linear indusium with the sori underneath, the flaps. Going for it, giving it a shot. It's great. It's a great thing. The world is better because this Asplenium is in it, and it's proud. Look at that, straight up.